Okay, so for section 1-3, measuring angles, this is a continuation of 1-2, which was measuring segments. Angles are also a very important part about geometry. It's the basis for a lot of what we do in geometry. So this is a very important section. So first of all, angles. This is the symbol for angle. I know it kind of looks like the less than or equal or greater than sign, but it's really, it lays flat, okay? So like less than and greater than, they kind of are like in the center here, while the angle symbol lays a little flat. So that's the angle symbol. And what an angle is two rays with an endpoint forming the vertex. Now this is a key term for angles. It's the vertex. It's the pointy part of the angle. But when there's multiple, we call them vertices. But the vertex is very important to understand what it is. It is the pointy part of the angle, the part where the two rays come together to actually form this angle. So the vertex on this angle is point A right there, okay? And so a key part about angles is how we name them. This is so important for the entire rest of the year because these type of naming schemes get used throughout the rest of the chapter. So if you don't know how to name the angles, if you don't know how to read names of angles, you won't be able to solve problems with angles, which is a lot of geometry, okay? So the first way to name an angle is by its vertex. So I can name this angle angle A because its vertex is at point A. Now remember, I'm not just saying A, okay? I have to actually write angle A because I don't know whether I'm talking about point A or angle A, okay? So that's a very important thing. So I can say angle A. Now the issue with this is this naming scheme does not work if I were to have, let's say, W, X, Y, and Z. I could not just name this angle angle Z. And the reason why is because if I just said angle Z, I do not know whether we're talking about this angle, or this whole angle right here. There's no telling what you're talking about when you just say angle Z when you do it like this. You can only do it when it is very clear that there's only one angle based on that vertex, which is why the second naming scheme comes in very handy. So the way this naming scheme works is with 3 points, a point on each ray and the vertex. Now it's 3 points. The middle letter has to be the vertex. And the way I say it is trace the angle. If I trace this angle, I would say angle BAC or angle CAB. I wouldn't say angle BCA. That's not focused on this angle. The vertex, the pointy part, has to be this middle letter. So this is very important for this angle. So I can call this angle WZX. Remember the vertex is that central angle, or the center letter. And then I can call this one angle XZY. And then I could call this larger one that encompasses those two, I can call that angle WZY, or even angle YZW. So that's a very important reason as to why we can name them this way. And the last way also comes in handy. They will just be small numbers like angle 1. You see how there's a 1 in here. Now notice this is not talking about the degree measure of this angle at all, okay? These are small numbers that will be put in here, usually ranging from 1 to 8. They wouldn't be like if this said I was 40 degrees. That is very clearly a measure of that angle, one that I just made up, but it's a measure of that angle, okay? So that's an important part here. I would say angle 40. It would say angle 1 for this one. Okay. Then we denote angle measure by saying the measure of angle blah. So I can say the measure, since I made up this number in here, I can say that the measure of angle WZX, and I'm going to write that down here. I'm going to write it the other way. Measure of angle XZW equals 40 degrees. So I put the little M in front. That stands for the measure of that angle is 40 degrees, okay? So now we're going to talk about congruence as it relates to angles, okay? Remember, congruent always means that it's equal. So it's these two angle measures that are equal. And the way, so remember in segments, if we were to denote that two things were congruent, I would denote it with little dash marks. Those dash marks would tell us that those are congruent and therefore equal. Well, in drawings, okay, in angle drawings, we use these little arc marks. So if I wanted to say that these two angles were congruent, okay, I would put a little arc right here and a little arc right here. They don't have to look the exact same, just showing one arc. So now I know that angle XZY must also equal 40 degrees, the measure of it. Okay, so that's something to keep in mind here, is those little arc marks. Now let's talk about the four different types of angles. We have an acute angle, which you guys all know is less than 90 degrees. We will never have an angle that is 0 degrees. It's not possible. So it's greater than 0 degrees, but less than 90 degrees is an acute angle. So cute because it's so tiny. So that's a very important thing right there. Next up, we know, you guys, we have the 90-degree right angle. Remember, unless it has this box or the problem says it is a right angle, you cannot just assume that this is a right angle. No matter how well I drew it, you cannot assume it has the right angle unless the problem starts with it having the box, okay? Or if the problem says this angle, let's call it T, the measure of angle T equals 90 degrees, then you're like, okay, because it says that, I know that this is a 90-degree angle. But without that information there, I cannot assume that this is a 90-degree angle. Next up, we have obtuse. It's greater than 90 degrees, but still less than 180, so it's not quite a straight line yet, or straight angle. So those are big angles, they're obtuse. And then next up, we have straight angles, okay? And you'll see here, I have this abbreviation, and this is for supplementary or straight line. So on a straight line, we'll have a straight angle, and straight angles equal 180 degrees. So every time you see a straight line, okay, you should automatically think that that's 180 degrees right there. So then if I have something cutting this in half, which I'll get to in a moment, I know that all these added together must equal 180 degrees. Which actually gets me to the angle addition postulate, okay? The way that this works is just like segment addition postulate. We still have the part plus part equals whole. So I can say that the measure of angle AOB plus the measure of angle BOC would give me this whole angle. So I'm going to pretend to make up numbers right here. If I have that this angle is 70 degrees, okay, and this angle is 30 degrees, then angle AOC must be 100 degrees. Same thing, and it goes with straight angles. If I have this straight angle, and these two angles are adjacent, they have a vertex right next to each other, and if this is 120 degrees, and I know this whole thing must be 180 degrees, this angle must be 60 degrees, right? We can set up an equation here. I can say 120 plus what equals 180. And so that's how I can figure out that x equals 60. So that's an idea we'll be working with a lot. And you may be like, why would I have to write that out? Clearly it's 60. A lot of problems, you'll use a little bit more complicated versions of this. Same thing. So you'll want to do this when it gives you the whole, but if it tells you it's a bisector, okay? So remember going back to measuring segments from the last section. Since these are equal to each other, this is 40 degrees, I know that ZX is a bisector. ZX is a bisector. Bisector, because it cuts this angle in half. So that's a key way to use the term bisector. So we talked about midpoint with segments. Bisector goes with angles because it cuts this in half. So if this was a more complicated problem, like if we didn't know that this was 40 degrees, but we knew it was 3x plus 15, okay, we could go about solving this problem because it's a bisector. We could set up an equation. 3x plus 15 equals 40 degrees because midpoint and bisector. So that would be something we would have to do here. I also, with measuring angles, I want to actually measure an angle here. So I have a protractor somewhere. Right there. Lost my protractor. And I want to show actually how to measure an angle using a protractor, okay? So on a protractor, you'll have this little center point. That's the center of the protractor. So that always goes on the vertex of the angle. So now we can move this however, but that vertex stays on that point. So now the next thing is to put that on the vertex and then line up one of the rays with that bottom line. Okay, so you see how this line is lined up with that bottom ray. Now, you'll notice on this protractor, we have two ways to count, the inside one and the outside one. It's never one way or the other. If we look, I moved it over here, I should always start counting at 0, which is the inside one on this way, but if I started this out on this ray, 0 is on the outside. You're going to get the same measurement no matter what, but you do not want to start counting at 180. Because if I start counting at 180, then this would be a 140-degree angle. Does this look like a 140-degree angle? Does it look obtuse? No. So I can see 0, this is a 40-degree angle. I know you can't see that on there, but that's 40 degrees. So this is a 40-degree angle. So that's an important thing to know about how to actually use measuring the protractor. Now, let's say if it gives us the protractor and these are on random numbers. Okay, I'm going to show this. These are on 2 random numbers. Now, the book does this a lot. So I can use either the inside or the outside. I'm going to use the inside here because they're smaller numbers and easier for me. So this is at 70 and this is at 30. So if I'm wanting this, it doesn't have it going all the way down here. So I know that this whole part is 70, but I don't want this 30. So I can do 70 minus this 30, and I still get that this angle is 40, the same way I got if I lined it up properly. So there's a lot of ways to go about it. Remember, the angle has to go on the pointy part, though. Remember the practice problems down here, textbook page 19. Remember, on the textbook, we have our vocabulary, we have our key concepts, we have the drawing that we put out here, how to measure these angles. We have example problems that our textbook online goes over in detail, each one of these example problems. We talk about how to name, so you look back at your notes and you make sure you name them, all the different ways that you can name these angles, okay? So make sure you're doing each one of these problems. Now you guys notice this says EP, that means extra practice. It means after you finish these, if you've got this concept, this gets you thinking about some other ideas with this concept. So those are extra practice. They're not required. I highly recommend you guys doing them. They're very helpful in that sense. So that was section 1-3, measuring angles, okay?